thank you guys all for joining us here for another ICM webinar. This is brief training on ICM's latest electrical disconnects with built-in internal surge protection. And this is the ICM 495-30A and the ICM 495-60A. These are listed in all the current price sheets, and we are producing these now. So we're actually getting a lot of pre-orders on these too. A lot of excitement around this product. I think it just makes a lot of sense. Surge has been growing rapidly, and this saves a lot of time and effort, wiring and so on. These in adding. So let's go ahead. We'll burn through this thing. Why use electrical disconnects with surge protection? Dirty power is becoming more common every day. We do see it in a lot of markets, and everything, and all that. Just makes sense to add surge as a low-cost insurance policy and protect those compressors. Harmful transient surges take stuff out in one hit. If you don't have protection in there. So inverters very expensive and costly to change. Any contractors that have ever had to change an inverter board in the field under warranty, just a big time drain, and it costs a lot of money. You'll spend half a day changing out inverter boards and mini splits and things. So makes a lot of sense to have a surge in there. Or even a 493 for inverter equipment, which has an onboard contactor to take the equipment offline. But if you just want basic surge protection, the ICM 495 series makes a lot of sense. It'll extend the life of the equipment and, hopefully prevent you callbacks, which are obviously very costly. What is a transient power surge? So transient spikes, surges, referred to, same thing, referred to by different names, but there are peaks in voltage that are extremely high in amplitude, but only last for a brief amount of time. So we have a little example here on the side, very short duration. And, you may have a line monitor on there that's monitoring your over-under voltage condition, but that has to see kind of a sustained condition for it to take the contactor offline. Or in the case of the 493, the onboard contactor offline to protect the equipment. A spike is such a rapid event, and it can be catastrophic, but it's such a rapid event that it sneaks right past a line monitor. They're two very different animals and are offering protection in a different way. Lightning strikes are probably the most common cause of transient spikes, and they can cause complete failure to an unprotected system. So where do spikes come from? From a variety of different places. Lightning strikes, power outages and recoveries down power lines, startup or shutdown of large equipment, equipment failure, short circuits, a variety of different reasons why one of these can happen. And you can see on this circuit board here, what can happen as a result of a transient surge. Pretty ugly. And then, so why do you need one? Well, this is a slide from a previous presentation that we did, but any disruptions in the chain and, blown transformer for whatever reason, lightning strikes, can cause surges, spikes, and dips, brownouts that are equally harmful to a system. But those you need a line monitor for. Surges, though, will help protect from those spikes in the line that can cause damage to the equipment. So power plants generate electricity. Then they have to step up the voltage from the generation plant so that it can travel long distances. So the big giant power poles out there, the big tall metal poles, that span across the countryside, that stepped up voltage. They need to step it up so it can travel those long distances, and then transmission lines carry it down to the substations. Substations break the power down, they step it down. Industrial facilities get power first at 600 volts, and then they'll step it down again to 460. And a lot of our commercial applications, any commercial mechanical contractors that we deal with, typically not a residential thing, but for the commercial facilities that are running on 460, they get it next, and then they step it down again to come into residential homes at the 230 volt. There's a lot of things that can happen in that chain, and it could be at any stage in that chain that could cause disruptions in the power flowing downstream from that. You know, a car hits a power pole, tree limb falls on a power line, takes out a transformer, whole variety of things. There can be problems at the incoming power at the house where the meter plugs on to the panel, and just a number of different things that can happen. So we need protection from those surges, and the way we do it is by using in electronics we use TMOVs, and that's a thermally protected metal oxide variable resistor. They come in different shapes and sizes, and there are different grades, different quality aspects of these things. But what you'll typically see in like power strips and things of that nature, you're going to see these little through-hole MOVs, and they stake those in there. Oftentimes you'll see these things, they're kind of doing their job, but they get fried. They get fried pretty dramatically a lot of times. So there's other devices that offer a higher level of protection than that, and that's these type of I don't know if you can see my cursor on the screen, but type 1 here, surge protection devices, TMOVs, that we use in our equipment. And I do have some pictures of one of these cut apart. Normally it would look like this, one on the left, and engineering gave me a couple of samples with the cases cut off there, so you could kind of see what was inside there. But so these little blue plates are essentially like this image here to the left. And what's inside these things, inside a TMOV, are zinc metal oxide grains. And the zinc metal oxide grains have real good heat dissipation characteristics. And so what happens with the device, when a surge occurs, there's heat that comes along with it, and the resistance of the TMOV lowers so that it draws that surge or that heat inside the device. And then heat travels from hot to cold, so it's bouncing around on all those little metal oxide grains inside there, trying to dissipate the heat. If there's enough capacity, based on the amount of the surge, the TMOV, the zinc metal oxide grains in there, can dissipate that heat away with no damage to the TMOV, and then it just keeps plugging along. The surge may be large enough that it melts or fuses some of those metal oxide grains together, in which case it's not one and done, it's not shot, but its capacity is degraded. So capacity is diminished based on those fused metal oxide grains, but there's still a whole bunch of them that are intact and able to take that hit and dissipate heat. And they'll continue to do that until they're done. And as you can see, there's in these devices on the right, the ones that are actually in our 518s, our 530 series, they're in this 495 series. Each of these plates has capacity to take those surges and continue to take the hit. But then we have two of these blocks in each device. And this is offering 100,000 amps of protection. So two large thermally fused metal oxide variable resistors offering 100,000 amp protection, which is more than you should need. We don't have issues with these. We don't have people calling back saying, hey, this thing didn't work. These things should typically work twice the capacity of competitors, and they should take the hits for a long time. There is an LED status indicator on the device that will show you, that'll tell you if your if you have protection, if the green light is on, you have protection. If the green light is out, it's time to change it. Applications for these things, obviously the disconnect surges are type 2, so they're used for a single breaker or a single device. Most of the time you'll see these mounted. Most of the time you'll see a type 2 surge mounted on the disconnect, below the disconnect outside, like our 517 or other devices. Now that we have this thing internally mounted, already wired up, should save a lot of time and trouble for a contractor. But they're going to use these on air conditioning condensing units, heat pumps, ductless mini split, maybe VRF equipment. VRF is three-phase, so we've got the three-phase surges as well. But the commercial, these are single-phase, so you won't see it on a three-phase piece of equipment, just to clarify. But and commercial refrigeration, reach-in cases, this type of thing. But they're designed to protect all single phase 120 or 240 volt equipment, and the wiring is very simple. Transient, over voltage. I think I may need to correct this slide though, because I think these are just 240. So this must have gotten in there from another presentation. Apologize for that. Transient over voltage and natural cause surges. I'll make the correction on that slide. So this is what they look like. 30 amp fused. You see the heavy ground strap on here. This is a UL requirement. They didn't want a single wire that could break and compromise the ground. So we have these robust ground straps on there. This is the 30 amps are a fused disconnect, and they are pre-wired. So you see we've got a black wire and a green, a ground. And so we've got this line wire here and this line wire here on this side. So you hook these up to the line side inside, and then the ground wire to the ground strap, and then your wiring coming in at the bottom is just like normal. And I've got some slides on that. This is the 60 amp non-fused. And you notice that the up here is white. This is kind of an engineering sample. I just didn't have an updated picture of the finished product that is pre-wired. So this one you'll also see it wired. You'll see, this black wire on the line side. You'll see the other black wire on the line side, and you'll see the ground wire hooked up to the ground bar. And so when to use a fused and a non-fused. Standard fuse disconnects use a class R fuse. We've all seen these to protect against high short circuit, and that's per NEC 109. Short circuit is different. It's a different event than a transient spike or surge. So it's a more sustained event, and a short circuit is just a dead short, right? What we're looking at is that temporary spike. So this fuse is not necessarily going to protect you from that. Time delay, these are slow blow fuse. It's a different animal than what the surge protector is. Standard disconnects don't protect from that rapid spike or surge necessarily. Fuse disconnects are used as a safety device. Any disconnect, it's used as a safety device to make or break electrical circuits during installation and servicing of the equipment. Oftentimes required. Fuse disconnects are often required by local electrical codes. So that's what you go by. Standard non-fused disconnects offer no short circuit protection. There's not a fuse in there, so they aren't doing anything. So it's even more critical to have some safety devices on there. But non-fused are used as a safety device to make or break electrical circuits during installation and service of equipment, just like the fuse versions. And standard disconnects do not protect from rapid surges or spikes. You have to include that in there. So make sure I'm not skipping a page. Warranty. 495 is now covered by a limited lifetime product warranty and a 3-year, $10,000 connected equipment warranty. If you want to view these in more detail, it's a pretty elaborate warranty certificate available on the website. So just go to the website, go to products, go to 495. Well, you go to surge protection devices, and then the 495 is under that, and you can drill down in, and the warranty certificate is right there below the sell sheet and the installation guide, and then there's the warranty certificate. Looks like other people's warranty certificates, same type of coverage, and it's that part of it's all pretty standard. So if you have any questions about that, by all means, let us know. But features and benefits of this, of our ICM495 series. Well, I guess it is 120 VAC single phase, 240 volt split phase. So split phase just refers to a residential panel. You have two 115 volt bus bars to make the 240 volt. If you I'll move on. Features, and internal field replaceable surge protective device, and that's this black device here on the upper right of the picture, to the right here. Built-in internal surge protective device replacement number is an ICM 495-sub, and is a field replaceable device. There's some criteria to that, which I'll cover. Maximum surge current rating of 100,000 amps, and then highest UL rating for nominal discharge current is for increased longevity and durability of the SPD. So we've got the highest rating for.
Hey, can I jump in there just a quick second for you, Ken? Or Keith, sorry.
Yeah, John Finetti,
yeah,
our tech director. Yep.
Hey, great job, Keith. Everything's going really well. This is great information. I just wanted to just clarify that 20 KA. The reason why the highest that UL will test to is 20 KA. And what that is 20 KA is the amount of surges that it can take over 15 hits. So what they're doing is they're hitting it with 20,000 amps 15 times and seeing how we survive.
I see.
And so that's the number of hits it can take. Let's say 15 hits at 20,000 amps. Just to clarify that.
Yeah, thank you for clarifying that, because what I'm used to seeing is 200 KA for like a direct short circuit, and that kind of threw me a little bit. I didn't quite understand that bullet, so I appreciate that. But yeah, it's got two high quality thermally protected TMOVs in there. And it's completely factory wired for a quick and easy installation, so it should save you a lot of time in the field. NEMA Type 3 rated, powder coated metal enclosure for indoor or outdoor use, and we've got knockouts in the bottom, no disassembling required, and then that braided ground strap, which was an important feature, especially for UL. Competitor pricing. So our pricing for the ICM versions of these related to other players in the market. Mars has disconnects with built-in surge, as does Rector Seal, but our 30 amp fused version, $99.46 compared to the other guys at $114.09 and $122.76. Ours does come with fuses as well. I'm not sure if theirs does, but fuses will cost you $10 at the hardware store. So 60 amp, our price of $103.39 versus Mars $148.47, and then Rector Seals at $139.21. Maybe some other pricing levels out there. We have deals and specials of our own. As a matter of fact, we have some specials going on right now for June and July for distributors, for large volume orders, and even some other specials going on that our reps and sales personnel should be passing around to all the distributors out there. And then hopefully some of that stuff gets passed along to the contractors, and everybody wins. So, best in class ratings at the best value. We're all American made. The other guys are not. And so we've got a little leg up, I think, on this stuff. We've had surge devices out there for quite some time. We make the best products in our categories in the industry. I firmly believe that. Been with ICM for a lot of years, and I just really believe in the products and what we're doing. So 100 KA single event compared to their 50,000. Ours is 100,000 amps compared to their 50,000, twice the protection. And then the 20 KA, 15 consecutive events. Oh yeah, there's that listed there, and they're only rated at 10 KA. So it's just a superior product for less money. I don't know how that doesn't win every time. So UL certification, both surge protector and disconnect combined, easy. And you see, we've got the check marks, right? Easy installation, factory wired, included fuses. So theirs do not have the included fuses, looks like. And we're American made. Size, pretty standard. Ours is a little smaller. Internal surge protection. And so Mars has it, the Rector Seal doesn't. You have to add that to the outside of the box, which is essentially then like our ICM495, adding that, which has the same level of protection as the 495 disconnect. So this is a type 2 ICM495 30 amp and 60 amp disconnects are type 2 surge. And what that is, type 2 is on the load side of an electrical service panel, so downstream from the main breaker. Field replacement of the SPD requires field evaluation by UL certified engineer or competent field evaluation body to determine compliance and all that. Field evaluation body will apply a field label to protect to the product to indicate that the product has been evaluated and issue a report to the authority having jurisdiction. And but it is field replaceable, which is nice. Wiring. I just put these lines in here to show you, this line wire is already going to be hooked up, pre-wired. This ground wire already going to be hooked up, pre-wired. This line wire also going to be hooked up. And then you just bring in your line and pair that in here, take your line to the other side, and then ground to ground. Then you take your load wires and hook those up accordingly. Load to load, and then to, yes. Yes.
So what is it you're doing today? Work. Oh, gee.
Hey, if you guys could mute, I would appreciate it. And then the non-fused version, 60 amp. Once again, we're pre-wired. So you're going to have this line wire already hooked up, this ground wire hooked up, and this line wire hooked up to line. And then you just bring in your line to line, hook up your ground, and then load to load. So pretty straightforward, pretty easy. We do have an installation video out there online. Our rep up in the Northeast, Matt Valent, works for United Components up there. Awesome guy. He is a former field tech and really knows his stuff. And so he does our installation videos for us at a place up in Rochester called ITEC. It's a training facility up there that's training a lot of new contractors and everything, and they do a great job, and they're gracious enough to let us come in and use their facility. They have tons of different equipment in there, so we can always find what we need to hook up our new products and test them out. Great partner out there, ITEC in Rochester. But very easy installation, and so
Keith,
we won't.
Keith,
Yes.
Sorry, just to give credit where credit's due, this one was done at Upstate's York training facility. I just would give credit where credit's due. They let us borrow their facility to install that Upstate systems here in Syracuse.
Awesome. Okay. Yeah. We appreciate that. And Upstate's a great company as well. So we won't go through this video. It's fairly redundant with the things that I've been talking about here, and then the wiring is pretty straightforward. If you want to view the video, it's out there on the ICM website. You just go to the resources, click the resources tab from the home page, and you'll see training videos, and then just drill down. A lot of good training videos out there. Matt's video on the installation of this product is out there that you can take a look at, or it's out on YouTube. So you see this YouTube link here. So you can find it out there as well. But a little more detail, just shows him hooking up the wires basically. And then, so we do appreciate it. Like I say, this is a pretty straightforward product, so we knew we were going to kind of get through this thing pretty quickly. We've got the media library out there, which has all the information you could want. Training videos, we've got product images, we've got PIM data, we've got cross-reference. A lot of this stuff's downloadable in Excel formats, so you can load it into the system very easily. Application guides, sell sheets, all of it's out there. Lots of product info, different videos and things available on the website. We do have a couple of promotions going right now. That, like I say, the reps and salespeople should be sending those out. And then, what am I missing? Jesse, anything?
I don't think so, Keith. If anybody does have any last minute questions, you could put them in the chat or the Q&A. Some of the texts have been answering, for the most part, all the questions that have come in so far.
Oh, okay.
Hey, Keith, this is Randy
Yes.
Inman. I do have two questions. I'll ask them both and then mute my line. Number one is, for the orders that are in-house now, when do we think they'll start shipping? And number two, what's the process for changing out that surge protector if it does go bad?
Yeah, so items are in production. And as far as I know, I think they're going to start hitting in August. If somebody can internally confirm that for me, I think we're going to start shipping those in the August timeframe. And then the process for the field checking, is Eric on the line?
He is here next to me, if you need to ask him a question.
Or John, as far as certifying, the change out and all that, is there what would be the process for a contractor in the field? I mean, so the change out itself, it's 2 screws at the bottom of the device.
It's more than that, Keith. It requires quite a bit of disassembly of the unit to get that surge protector out of there.
So there's good news and there's bad news on this topic. UL will not allow us to change out the surge protector embedded in the product unless they have a field engineer from UL come out and inspect the installation of it. The good news part of this is that the I nominal rating is the highest attainable rating that you can have, that UL will test to, such that we don't expect failure of the surge protector in general.
That's at 20 KA that we were talking about, Keith.
So essentially, we'd be a lot better off just to change out the disconnect as opposed to
At
changing
the moment,
out the.
at the moment, yes.
Okay, all right, that's fair enough. I mean, probably just as easy anyway. And then, price wise and that kind of thing. Don't know what all that looks like, but yeah, that's a fair question. We'll as soon as we get more information on that, we'll let you know. But I guess just plan on changing out the disconnect if the surge does get used up. Fair enough.
Sounds good.
Yep. So if the green light is on the device, you're protected. If the green light goes out, and it's right at the top, so let me see, I might be able to go back to this. I might be able to go back to this screen here. Let me see. So see the little green light up at the top? You guys see in my screen?
Yeah.
Okay. So this little green light up here, if the green light's on, you're protected. Green light goes out, it's time to change out the disconnect. For now, change out the disconnect. All right. So any other thoughts or questions? Pretty straightforward. All right.
Hey Keith, were you gonna send out this PowerPoint?
Sure. Yep, I'll send it out to you guys, and
It will be listed on the media library as well tomorrow. By tomorrow, it will be edited and put up there. So
Yeah.
when you go to the website, if you just click on resources, there's a new announcement coming on the ICM University, but also the media library is always there, and all webinars will be on both of those. So the resources tab on the ICM Control website is a great resource for these things.
Are we gonna make a fuse 60 amp?
Not in
Do
the
we need
plan at the moment.
yeah, do we need a fuse 60 amp?
I don't know. I gotta check the regs in California probably because of
Okay.
California, but
Most of the
Mhm.
60 amps I see are non-fused, but
Okay.
yeah, let us know. And
Oh.
you know, then it becomes a volume game, right?
right, sure, of course.
So but if it's keeping us out of markets where we can do something, you know, always willing to take a look at additional products and stuff.
Thank you.
So just real quickly too, if I might mention the ICM 870 series, that's our soft starts. The 32 amp has been approved, UL approved, and we should start seeing those by August as well, it sounds like. And that's really good because the 9 amp and the 16 amp goes up to about 2.5 ton. Obviously, there's a lot of 3, 4, 5 ton out there. And so the 32 amp will cover everything up to 6 ton. And really awesome product. Would encourage you to go out and look at some videos on that. Cuts inrush current by 70%. Matt Valent did a video on that as well. And the equipment that he hooked it up to, the amp draw was he was using a 16 amp, and it was for 2.5 ton. I can't remember what the size of the equipment was, but amp draw was 58 at startup, and he put that device on there and it cut it to like 7.8 or something amp draw at startup. So a lot less wear and tear on the equipment, soft starting of the equipment, better for the compressor, better for energy savings. And then if you're trying to start a piece of equipment on a generator, lots of backup generators out there these days. And if somebody wants to run air conditioning off of backup generator, it really cuts the the load necessary to start that equipment. Solar as well. So some really great products coming out, and we're always working on new stuff. So there'll be more webinars to come. As a matter of fact, Soft Start will probably be the next one. So we'll get the word out and hopefully see you guys on that one.
One other thing I'd like to add to the Keith's notes there is that when I field calls on these, the most thing that people comment about is how quiet it makes the equipment sound. They just love that fact because a lot of the air conditioners and so forth may be mounted near their bedrooms or in areas where they can hear it. And this really reduces the sound quite a bit.
Yeah.
So that's like a big plus for a lot of people.
Yeah, my air conditioner at my house, it sounds horrible when it starts up, and but it's like the shoemaker and the kids, shoemaker kids or whatever. I just need to get out there and install it, and I'm gonna check the amp draw before I start, and then check it afterwards, and certainly report that in. But I think it's also going to eliminate that sound. Plus, I get a little dimming of the lights and stuff when it starts up. All right. Well, thank you guys very much for joining in. Hope you got something out of it. Please go out to the website. All this information is out there, and Jesse will be pushing this presentation out there to the media library. So I would encourage you to go out there and grab it from there if you want it. Thank you all very much.
Thank Keith.
Okay,
Thank
you
you,
guys have a
Keith.
good day. Take care.